In this program, we're going to light up the LED strip one pixel at a time, using a variable to determine which pixel is getting lit. Anytime we use the LED strip, we want to include the ledstrip.h library. That gives us access to functions that are specific to the LED strip, like setPixel, draw, and clear. We also need to name our LED strip. I name mine strip, and we need to complete the LED strip function. It's got 3 arguments. First, how many pixels are on the LED strip? Second, which pin of the maker board is plugged into the green wire of the LED strip? And third, which pin of the maker board is plugged into the blue wire of the LED strip? Now that the LED strip is ready to use, we're going to create a variable above the void setup. We'll determine the type of variable we want to use here, and that's an integer, shortened to int, and that means that our variable value will always be a whole number with no decimals. Next, we name the variable. I'm naming mine pixel count because that's what this variable is going to keep track of for us, which pixels are lit up. You'll notice that I capitalized the C in count because when you have 2 words as a variable name, it makes it easier to read if you capitalize the second word. This is called camel case. Next, use a single equal sign and give the variable a starting value. I want pixel count to start at 0. There's nothing inside the void setup function here, but we still need this function and its opening and closing curly brace for the code to run. Inside the void loop function, we first have a setPixel function. And setPixel has 2 arguments. First, the pixel or pixels that we want to light up, and second, the color value we want to show on those pixels. In the past, if we just wanted to light up 1 pixel, we could use a number here ranging from 0 to 14. Instead, we're going to use a variable value to determine which pixel is set up each time the loop runs. So the first time this loop runs, pixel count will be 0, and the 0 pixel, which is the one closest to the colored wires, will light up. The second argument in setPixel is a color value, ranging from 0 to 299. Next, we have the draw function that sends that setPixel data to the LED strip and displays it. Next, there's a delay function with an argument of 1000. That means the code is going to pause here for 1000 milliseconds before moving on to the next line. So we'll pick a pixel, light it up, and display that lit pixel with .draw. Then we'll wait 1000 milliseconds before moving to line 16, which is pixel count plus plus. This plus plus increases the value of the pixel count variable by 1. So if pixel count starts at 0, when this line of code runs, pixel count is now equal to 1. On line 18, we have an if statement. If statements have 2 main parts. Between the parentheses is a condition that is checked, and between the curly braces are the actions that are run when the condition is true. Here, we're checking the value of the pixel count variable and using 2 equal signs to check if pixel count equals 15. If it does, the code inside the curly braces will run. The first line is pixel count equals 0. That single equal sign means that we are giving pixel count a new value. The double equal sign means we're checking a value. So pixel count equals 0 resets the variable's value to 0, and strip.clear clears off the LED strip. If the condition pixel count equals 15 is not true, the if statement is going to be skipped. Either way, when the code reaches the closing curly brace of the void loop, it jumps back up to the top of the void loop and starts to run the code again. So the way this code is going to run through is that pixel count will equal 0, so the first pixel on the LED strip will get set to a color value of 200. That draw command displays that 200 value on the first pixel. Then we wait 1000 milliseconds before pixel count plus plus means pixel count now equals 1. Pixel count does not equal 15, so the actions of the if statement are skipped. The void loop starts again, and now pixel 1 will get set to a color value of 200. We'll delay 1 second with that pixel on, and then increase the value of the variable again. If pixel count is 2, it's still not equal to 15, so the if statement is skipped, the void loop completes, and we run again. Remember that the pixel closest to the end of the LED strip is actually pixel 14 because we number the pixels 0 to 14. So imagine that strip.setPixel sets 14 to 200. Pixel count is now 14, and that's the pixel we're lighting up. We delay for 1000 milliseconds, and pixel count plus plus makes pixel count equal 15. At this point, our entire LED strip is lit up. When the if statement checks the condition, is pixel count equal to 15, the answer is yes. So the code between the curly braces runs, resetting pixel count to 0 and clearing the strip. The next time the void loop runs, it's going to start by lighting up pixel 0 with a color value of 200. So this is going to turn on one pixel at a time and loop indefinitely, always turning on one more pixel, clearing, and then starting over.